Welcome viewers. On behalf of Iravati Research and Communication Center, this is your host Pratim Ranjan Bose. In this edition of CEO Speak, we have a guest from Berlin, Dr. Ralf Gilgen, who heads the global consulting engineering firm service provider, Dornier Group. Welcome, Dr. Ralf.
Yeah, thank you very much for your time.
Based out in Germany, Dornier works in 5 major verticals, which are power and heat, renewables, mobility, water, and nuclear decommissioning. With over 20 subsidiaries in 11 countries, the group has a transnational presence. They have also opened an outfit in Delhi to handle businesses in South Asia. Dr. Ralf, before I ask you questions on India, if you kindly introduce viewers with the group and the major consultancy works that have been undertaken by you.
Yeah, I can do. Thank you for the opportunity here. Our group, Dornier Group, is a holding company and is driven by 5 business units. And we think ourselves are a leading infrastructure consultancy company, and we are focusing to the main transitions which take place in the world, which is the energy transition, the mobility transition, and we also see we are in the water transition at that point. So we have 5 business units, and when I start with mobility, for example, we are serving consultancy work in rail, road, and aviation. So we did, for example, a lot of master planning in Saudi Arabia for the railways. That means the large railway lines for the next 30 years. In road, we are have a lot of experience in toll roads and in traffic planning. For example, in the new city of Neom, we are doing the traffic planning, very future-oriented with hyperloops, for example. And aviation is coming back now after the COVID crisis. It went a little bit down because we consult airports. But airports are also now looking for decarbonization of their operations. This is a new business field where we consult airports. In the water side, we are more the groundwater experts. One of our famous projects is strategic reservoirs. That means large underground water storages, which we have built in Abu Dhabi, for example, and definitely groundwater management and water supply. We have a small unit for nuclear decommissioning, nuclear plant decommissioning. You know, Germany wants to step out of nuclear plants, and so the dismantling is not an easy task. This is radioactive material. And then we have the power and heat business. This is also the transition from coal to gas. Maybe we have a lot of district heating here, which has to be also green energy. And we are also doing a lot of O&M work and erection works in Germany as well as international. Most of our people are working in India, more than 1,500 people. And we're doing the operational maintenance for power stations there. And renewable business unit is focusing on solar, wind, and grids and storages. So we plan our the solar parks and the wind farms, but we can also erect them and do the O&M for these windmills. And what we see is that most of that comes with a battery, comes with an energy solution. So we have developed a fuel saver project, for example, in Africa, where solar power substitutes diesel generation. And so we save a lot of CO2 emissions with that concept. So these are the 5 business units, and yeah, we are proud to shape the future a little bit in that way.
Thanks. We will come back to this. You mentioned about Hyperloop. I'll come back to this at the end of the discussion if we have time. Dr. Ralf, coal and coal power has definitely made a comeback worldwide. Europe is reopening coal power plants. India always had a serious bias to coal, and for genuine economic reasons. It had now started building new coal power plants after a gap. At the same time, India, as joined the pledge to work for carbon neutrality by 2070. There are early targets to reduce carbon emission as well. And given the kind of natural disaster that we see, we cannot, there is no way but to take care of the environment. The issue is how can we meet how can we meet a common point between the coal power, need for coal power, as well as meeting the climate goals?
Yeah. So I do not see really a comeback of coal in Europe. The reason is maybe there is an extension of lifetime of coal-fired power stations, but the reason is definitely the crisis in Ukraine and the missing gas from Russia. So Europe and especially Germany was highly dependent on Russian gas. And this is stopped now. And for us, it's now a challenge to survive, let me say, the winter time if there is no gas. So at that point, we will not use gas for electricity production in the moment. We need it for our industry, for chemical processes, and for heating. And therefore, all other units will be reactivated. So all these power stations, which has to be on standby and which was planned to be out of commissioning, are now back. But this is a very short temporary effect. I don't think that is a new line. You mentioned the climate, and on one hand, we have to cope also with the climate change, and this is definitely not merging with coal-fired power stations, or at the end with fossil-fired power stations, also gas stations. No? So in our view, maybe a short-term effect. At the end, I think the world is going to be electric, and the primary energy will be electricity. It will not be gas or oil or coal at the end. And this transition, from our perspective, is led not by the climate change itself, it's led also by the economy of the electricity production. And maybe here in Europe, it seems like a joke when I say electricity prices will be lower in future. In the moment, they are really quite high, but this is a little bit more due to trading. But we expect with the production of wind and solar power to get very low electricity prices, which will be the basis for our future energy supply at that point. And it is reliable, it's cheap, and it's carbon neutral at that point. All clean coal technologies, state-of-the-art coal-fired power station has an FGD system, means flue gas desulfurization, or a nitrogen oxide emission plant, reduction plant. But at the end, it emits CO2 in a big amount. And to use this CO2, it is so much. Yeah? It is not like nuclear waste. You have a few barrels. Yeah? It is more than three times higher than the coal input. What you have to dispose on CO2 or have to be reused, and that we do not see that we get somehow a economically viable solution to use on a long-term basis coal-fired power station.
Dr. Ralf, the Indian context is a little different in the sense that in Europe you pay very high price at the residential segment. It's not the same in India, and for a reason. We had a poorer mass, and we just ensured that the electricity reaches all. So we added huge generation capacity in the last decade, for 1.5 decades, let me put it. It's more than, I think it's now 3 times than what it was back in 2007-8, right? And meanwhile, in the last decade, we have expanded the RE capacities. So the RE mix in the total generation is now very substantial. the 10% threshold, if we remember. It is there. I think briefly it went above 10%. I'm talking only about solar and wind. I'm not talking about the hydel. So if we take that, that's very high. So the challenge here is to meet the common goal of affordability as well as the quality supply. I mean, that is the next goal. And this change in mix are surely there will be a lot of technical challenges to that. So how can that be addressed?
Yeah, first let me say definitely India has another challenge than Europe, that you have an increasing electricity demand and to connect all your people in India with electricity. I think this is the overall goal, because electricity means comfort, means education. Yeah, you have access to internet, so this is very important that everybody gets electricity. So to fill the gap, definitely you are in a transition phase, and still you have a mix, an important mix. In Europe, we are seeing that the renewables are taking over more of the electricity production. But I'm totally convinced that this development will hit you as well, maybe years later than in Europe, but the development will be the same. Means that we have electricity production on the long term only from renewables. The problem here is that, and I cannot deny it, and the sun is not shining in the night, so PV will not produce. At that point, maybe wind a little bit. So there is, when you divide the renewable electricity production into two parts, is one which can always fed into the grid because it's needed, and we have a surplus electricity. And the question is what to do with that. And we have times where the sun is not shining, the wind is not blowing, and you need also electricity.
The best power.
Yeah, and we see that the solution is to use the surplus electricity to produce synfuels. And with this synfuels, you can cover the gap when renewables are not operating. And when you calculate in Europe, I don't know the numbers for India, but in Europe, for example, it's only 80 days when you need a full capacity because renewables are not working enough at that point. So it's not so much. And there will be also in the industry, also in mobility, cases where you cannot use only electricity. You need these synfuels. And these synfuels could not be from fossil. They have to come from, have to be produced with renewable electricity. And our concept here is that we have developed a system which is a high gasification of biomass with electricity, which get a high output of synfuels at that point. So that will be, on a long term, will be our primary energy will be electricity, and with the surplus electricity, we produce, let me say, synfuels for the gaps which definitely occur in the world.
Now, with we have separate problems, different basket of problems, part of which you also suffer, Europe also suffers. Is that at the one side, that we have to reduce, India has to reduce the dependence on crude. So with the availability, excess capacity in electricity sector, we are now seeing the railways is completely converting into electricity, which was approximately 3.5% of total fuel consumption. So that's big. On the EV side, we are, India has taken a approach where we started with the most cheapest vehicles. So two-wheelers that consume two-thirds of the total petrol or motor spirit consumption, they are getting converted very fast. This has almost now become a very, very consolidated trend. And the cars will follow this. So there is a change in the whole electricity scenario. On the one hand, there is a mix of farm and inform electricity, I mean, rather in high mix of inform electricity, and at the same time, we are seeing that the EVs are coming into play, and they will draw power in the off-peak hours. So where, what kind of challenges that we are about to face, and the kind of solutions that we need.
Yeah, as I mentioned before, we see the word electric, and definitely all mobility will be electric, maybe with the exception of long distance flights, but also for trucks and vehicles and scooters, everything will be electric. We see it more positive because with, or let me say first, the refueling of electrical vehicles will be different to what we know now. Yeah, today, if the tank is empty, you go to a fuel station and refuel. But with electric vehicle, it's not often that the battery will be low. Yeah, so the cars are connected permanently. If you're not driving, the car is somehow connected to the grid, because then you will recharge that. Maybe like we do it with our mobile phone today. Yeah? You charge it every evening. You don't wait until it's down in the noon. Yeah. So the behavior of refueling electric vehicles is different. So now, assuming we have a system where we have a lot of charging stations and we have a possibility to connect your vehicle everywhere when it's not using, and the car is used only 2 to 5% of its time on a private basis, then we have access to a huge storage system. And this helps to store the surplus electricity and to flatten and to stabilize the grid at that point. And if you have a good tariff system, you can you can drive a little bit, whether it is charged in the night or it's in the morning or whatever. If you get better tariffs in the night, and maybe your private car, you come at home in the evening, it doesn't matter whether it's charging on right in the afternoon, late afternoon, or in the early morning or midnight or whatever. So load management systems according to the demand and supply can really flatten it a little bit. So we do not see big peaks at that point. And if you count it, you have an immense electrical storage with mobility at that point.
Okay. So it doesn't, it doesn't require any reconfiguration of the systems. That is what you mean?
Yeah, every charging station.
Reconfiguration on the part of the system. I'm talking about the distribution system. Does it require any kind of reconfiguration?
No. At the end, the load, if it is distributed even in the big cities, if you have an intelligent load system, you don't need much of these of bigger cables or more capacity to the household at that point. As I said, the charging will be different. And if you look, I don't know your personal car, but you don't drive a day or that the car is empty, that you have 400 or 500 kilometers. And we expect with the new generation of batteries, maybe you reach 800 kilometers or even 1,000 with that. So what you charge is, imagine you put your mobile, if you don't use it, on a charger. You will not discuss on that. And it's only a little bit what you have to recharge at that point. So that's not the case. Where you have to see if electric trucks comes and you have this long distance highways, then it is a case, and we have a few projects, especially in Eastern Europe with that, where you say maybe for 400 or 500 kilometers, the trucks will come, because every truck, when it starts in a big city, will end up at that point. And currently we are designing really large and fast charging stations for trucks at that point. Then that's the only case where you have a peak. Because this truck is used professionally and it's always driving at that point. And if you have this fast, and they need this fast charging devices, and if you have 50 of that, definitely you have to see where you install these points, and you have to bring the capacity there at that point.
I agree.
But
So
we don't.
So it means that a lot of clarity will emerge with time. One is, you mentioned storage will be an issue. In India also we see the emphasis on storage. Also we see nowadays they are bidding hybrid projects. So that's one side. And at the same time, on the vehicle side, some more technological advancement is expected over the next few years. So that will finally settle down the dust and bring in kind of a certainty in the system.
Yeah.
So you work a lot, you mentioned about your work experience in the water side. Now, in India, we are seeing a peculiar situation. All transitional economies do face this kind of things. Firstly, our population will keep growing for next 20, 30 years. And we are urbanizing at a fast pace. So put together, there is the dependence on agriculture or the demand for food. All put together, what we are seeing is high withdrawal of groundwater. This is a phenomenon, and particularly in city environments. If we see all Indian cities, it has the water crisis is looming in some way or the other. If it is not a crisis of quantity, then it is surely a crisis of quality, because when you are drawing from the ground, there are a lot of issues with that. So all put together, what do you see the water side emerging in India, and what kind of challenges and solutions that we have to look for?
Yeah, water will be a challenge. Since the other topics which we covered, we have a kind of solution, and we are in the transition phase. Water will be a difficult issue to get access to potable water. One definitely is groundwater, but what we see, this groundwater behavior is very, I think sluggish is the right word. Yeah, so you cannot change it. Even if you want to change it, it takes 20, 30 years at that point. And what we observe, we have done a lot of survey in Arabia on the groundwater, that there the groundwater level in some portions has decreased for 130 meters, because everybody took out the water. And if it is not if it's inexpensive, it costs nothing, then everybody is doing that. So the first issue, I think, is to make aware that even groundwater has a value, and it has to be paid. That only the economics counts. Yeah? If something is expensive, then people are treating it a little bit with more respect on that. And so there, for example, we installed over 13,000 water meters, so that people has to pay if they take out groundwater. Unfortunately, what we observed is that the groundwater is, in many cases, has not the quality of potable water anymore. So you have to clean it at that point. And this is definitely expensive. And it is the same like you have to dissolve seawater. It's also very expensive. Our solution is that if we see, and then the circle closes, the low energy prices, what we expect, give you much more possibilities also in water desalination. Either it's seawater or it's groundwater at that point. So if we have calculated that as a model, if you desal the groundwater or the seawater completely, you can harvest the salts and the metals in the water, and then you have another revenue stream by selling those materials. And when we look at the prices which are on the market, maybe 2/3 of the price can be recovered by selling those salts and those metals which are in the water. And this is also an economic solution, because we still believe only things will happen if it's economically valuable. Yeah, the state or with subsidiaries, you can accelerate everything a little bit, you can initiate a little bit, but on the long run, systems must be economically viable. And this leads to very low freshwater prices if we do it in a large scale. And this allows you as well to water the fields for agriculture and so on. So this is a complete circle, what you have there. And yeah, currently we are a little bit advertising that system, looking for investors to make the first pilot plants to show that this works. And this is definitely something, also a solution for India to get access to clear and water for everybody.
Before we wrap up, let me go back to what, in this Hyperloop. Now we hear about these solutions. The solutions are interesting, but from Indian context, I tell you the issues we have on the mobility side. Capital is one of the issue that we haven't discussed, or we discuss less. And it is very important in our kind of context. So with, say, metro network is very costly at 300 to 500 crores a kilometer. So it's pretty costly. Now, we hear about hyperloops and these things. I mean, are there more futuristic, this kind of, what is the status of these projects? I mean, will they be cheaper? Will they be more viable?
Yeah, I think in the future it will be viable, and where we are planning that in the moment is a new city. And if you start from the scratch, yeah, it is easy to define new lines. And our target here at NEOM is that in the new city, in the line, you come first public transport from one point to the others in 20 minutes. And therefore, this is only possible with Hyperloop, with all the problems it still has, but it will be the future. I look at Mumbai, at Delhi, at Calcutta, everything is full. So maybe the transition at that point will be difficult, but with this high velocity, I think it's better to cover longer distance at that point. So it will come, but maybe it's not the solution for every city in the world in the moment. Yeah, if it's existing cities, it's difficult to do that.
Thank you so much, sir. Thanks for the interview.
Welcome.